Okay, so you tested how well your model generalized to a held out test set. In this tutorial, we're going to think more about generalization and more about different types of generalization that might matter for how you evaluate your model. So, first, we're going to learn about the concept of within distribution generalization, and then also the concept of out of distribution generalization and how you can test your model on that second type of generalization. So when we talk about within distribution generalization, that's what you just did. It's that you have a data set and you randomly split it into test and training. You train on the training data, you test on the testing data. But that test data still comes from the same distribution as the training data. So for example, for a given scenario in our data set, maybe the locations in blue were the training locations and the locations in red were the test locations. That could be how the split happened. And in this case, you can see, the red points are different than the blue points. They're different, but they're very close to the spatial locations that were in the training set. So this still is testing for generalization because the model doesn't have a chance to memorize all the red points because it didn't see those red points in training, but it did see very similar things when it was training. So this is within distribution generalization that you just tested. We can also think about, and many people care about, how a model performs when it's tested on something that differs a little bit more from what the training data looks like. So for example, if you trained your model within this whole blue box you got the training data from, and then you tested it on locations in this red box, now you're testing on locations that are further away from the training data. They're a different distribution. They're kind of slightly outside the distribution of the data that it was trained on. And so in this way, you're testing how well the model generalizes to this different data that is even more different than just the test set within the area that the model was trained on. So out of distribution generalization is, as you would expect, more challenging because you're making the inputs to the model more and more different than the ones that it saw during training. But at the same time, in most real world applications of machine learning, a model needs to have some ability to do this kind of out of distribution generalization because the data that will be given when you're trying to solve real world problems might differ somewhat substantially from the training set that you had. So out of distribution generalization is a really important topic in machine learning. So now you're going to get to do what you just saw in that previous slide of training your model on the blue region and testing it on that little red region that is spatially separate and see how well your model generalizes to new spatial coordinates.